And so for number 3, we've got to recognize that we have some nasty fractions here, and we want to employ a trick that we have used in the past to make the fractions go away. And so, for example, if we had something like 2/3 x plus 1/4 equals 3/5, we could find a common denominator, like 60, multiply both sides by 60, and then our fractions would divide out. We would end up with 120 over 3x plus 60 over 4 equals 180 over 5, and we would then have only whole numbers. We would have 40x plus 15 equals whatever that is, 36. And then we could solve from there. So the thing to remember, bring back from the past, is we can do anything we want to both sides of an equation, and it's often very helpful to multiply both sides of an equation by a common denominator to make the fractions go away. So I'm going to erase my little example here, and we're going to apply that idea to this problem. We're going to find a common denominator. It doesn't have to be the least common denominator. It could be any common denominator. And we're going to multiply both sides by that common denominator, and then we will see that the fractions will divide out. So to start, we take both of our denominators, x minus 4, which we cannot factor, 2x minus 8, which we can factor to make 2 times x minus 4. And so we see that we have the unique denominators, we have the unique numbers 2, and x minus 4 is in both spots. So our least common denominator is 2 times x minus 4. So we are going to multiply both sides of this equation by that common denominator, 2 times x minus 4. And so here we go. And we'll do it over 1. So then times negative 3 over x minus 4 is equal to 2 times x minus 4 times that first part of this one, so negative 5 over 2x minus 8. Don't forget your negative there. It caught me earlier when I was trying to do this. And then plus 1, or we'll put the other piece first, 2 times x minus 4 times 1. And so what we'll have next is we'll go ahead and multiply this out. So we will end up with negative 6 x minus 4 over x minus 4 is equal to negative 10 x minus 4 over 2 x minus 8, and then a plus 2x minus 4 over 1 times 1, which is just 2 times x minus 4. And so what we've got to notice is that here, that x minus 4, if I factor that denominator 2x minus 8, I will have an x minus 4 that is going to cancel out for me. So my next piece is going to be to factor that denominator. Two times x minus 4, and then plus our 2 times x minus 4. This problem is particularly nasty. So now we need to do our canceling. So the x minus 4s will drop out there. The x minus 4s will drop out here. That negative 10 and that 2 will play together to make a negative 5 over 1. And we can see that because we multiplied both sides of that equation by a common denominator, all of our fractions are disappearing. We are left on the left side with negative 6, and on the right side, negative 5 over 1, which is the same as negative 5, plus 2 times x minus 4. And so the next piece for us, we just have a regular looking, somewhat nasty equation now. We can just go through the regular solving process. So we're going to simplify the right side. So that will be 2x minus 8. We'll continue simplifying the right side. Negative 13 and 2x, so 2x minus 13. We'll add 13 to both sides. And we will have 7 is equal to 2x. We divide both sides by 2. And we end up with 7 over 2 equals x. So I'm actually just going to go ahead and move that over to the side here so it's not like right in my other problem. But that's how we got there, everyone. First thing is to recognize we can make the fractions disappear by multiplying everything by a common denominator. And we end up with 7 over 2. Last piece is to check in our original equation and make sure that if we put 7 over 2 in there, we would not be creating 0 in the denominator of any of those fractions. And just giving it a quick look, putting 7 over 2 in there would not create 0 in any of those denominators. So 7 over 2 is a viable answer. I hope this is helpful.